hello, good day everyone. We hope you are doing well. We are from Group 1 that consists of me, Balkis, then Stephanie and Viola. Alright, here we will explain about Cantor's disappearing table.
The content of this video is that you will know the history of the founder of the theory of infinite sets in mathematics, then the application of the theory itself, and the proving of the theory.
Okay, first, let's talk about the founder. George Cantor, or George Ferdinand Ludwig Philipp Cantor, was a Russian-born mathematician who can be considered as the founder of set theory and introduced the concept of infinite numbers with his discovery of cardinal numbers. He shared about the conception of transfinite numbers, to which he was led by his demonstration that an infinite set may be placed in a one-to-one correspondence with one of its subsets.
So we will start with a table with the length L, so you can see that the length of the table is L. Let's remove a quarter of the table from the center, so it means we leave two pieces in the sides. And the remaining pieces each definitely have a length less than 1/2 or a half L, right? And then let's remove 1/8 of the table by removing 1/16 from each of the remaining sides. Remember that 1/8 is equal to 1/16 plus 1/16. Each of the remaining pieces have a length less than 1/4L or a quarter L. Next, we remove 1/16 of the decks by removing 1/64 from each previous remaining piece. Each of the remaining piece have a length less than 1/8, right? And as we continuously remove this portion of the table, will the table eventually disappear? There are two ways to look at this problem. One way is focusing on the amounts removed from the table, and the other way to look at this problem is focusing on the amounts remaining. See the demonstration in the next slide.
Okay, thank you Balkis and Viola for the explanation. As we know, the problem requires us to prove whether or not the table will disappear if we remove only half of the table, starting from 1/4 and 1/4 times a half or 1/8 and 1/8 times a half or 1/16 and so on. To make the proof credible, we should remove the part of the table when n is equals to infinity, but it will be impossible if we try it one by one, because it will take a lot of times and it will be impossible. Thus, we need to use infinity geometric series where n is equals to infinity. And the formula that we're gonna use is S infinity is equals to A over 1 minus R. A in here is the first sequence or a half, and R is the ratio. R is the ratio when we can find it by eliminating 1/8 divided 1 by 1/4, or it's equals to a half. And then we just need to submit this number. So 1/4 minus 1 minus 1/2. Okay, let me remove this first. So 1 minus 1/2, 1 minus a half, it's equals to a half. So 1/4 divided a half, or 1/4 times 2, or equals to a half. So like Viola and Balkis already explained before, the disappeared table will be a half. So table will not disappear, but only decrease a half of the part.
Then, to sum up, Cantor's disappearing table is a geometric progression extending infinitely. Even though we continue to process an unlimited number of times, only half of the table will disappear. Alright, that's all for our group explanation. We hope you get the idea, and have a wonderful day everyone.